In question 1, we have to find the quotient and remainder when x power 4 is divided by x squared plus 2x minus 1. Now, a quick revision that let's say if we are dividing 7 by 3, so we write 7 inside, 3 over here, and 1 is our remainder and 2 becomes our quotient. So similarly, when we are dividing algebraic terms, x power 4 will be inside, we'll have x squared plus 2x minus 1. Now, in the first step, we'll divide x power 4 by x squared. This will cancel out and we'll have x squared over here. X squared into x squared, that becomes x power 4. X squared into plus 2x will become plus 2x cubed. And minus 1 into x squared becomes a minus x squared. Now we subtract, so we'll change the signs over here. This will cancel out, so we'll have minus 2x cubed plus x squared. Now we'll divide minus 2x cubed by x squared. We'll get minus 2x over here. So minus 2x into x squared, that will become minus 2x cubed. Minus 2x into plus 2x is minus 4x. And minus 2x into minus 1 is a plus 2x. Again, we'll change the signs over here. So we'll get, this will cancel out x squared plus, so this will be 4x squared. So x squared plus 4x squared is 5x squared minus 2x. And then we'll divide 5x squared by x squared. This will cancel out. We'll have a plus 5 over here. Now multiplying 5 by x squared, we get 5x squared. 5 by 2, we get plus 5 times 2 is 10x. And plus 5 into minus 1 is minus 5. Changing the signs, we will get, so this will be 5x squared and 5x squared will cancel out. And minus 2x plus 10, so this will become minus, so this will become minus 12x. And this minus 5 will come down as it is. And this minus 5, this will also change its sign. So this will become a plus 5 over here. So this will become minus 12x plus 5. So finally, our remainder will be minus 12x plus 5. And the quotient will be x squared minus 2x plus 5. In question 2, it says two variable quantities x and y are believed to satisfy an equation in the form y is equals to c into a power x. An experiment produced four pair of values that are given in the table below. By plotting L and Y against X for these four pair of values, you have to draw a suitable straight line and then estimate the values of C and A. Now in the first step, it says X is 0.9 and L and Y is 1.7. So 0.9 and 1.7 will be over here. 1.6 and 1.9. So this is 1.6 and this will be 1.9 over here. 2.4 and 2.3. So 2.4 and 2.3 is over here. And 3.2 and 2.6. So 3.2 and 2.6 would be over here. Now we have to draw a straight line, so we'll just simply join the points together. Once you have drawn the line, we have to use this to find the value of C and A. Now the equation given is y is equals to C into A power x. So first we'll bring it in the form y is equals to mx plus c by introducing logs on both the sides. So we'll have ln of y is equals to ln of c into ax. Now applying basic rules of logs, we'll write it as ln of c plus, and this can be written as ln of a to the power of x. Bringing x over here, we can write this equation as x ln of a plus ln of c. Now comparing it with y is equals to mx plus c. So this was plotted on the y-axis and this was plotted on the x-axis, which means the gradient will be is equals to ln of a and the y-intercept will be equals to ln of c. Now we can directly from our graph see that the value of the y-intercept is 1.3. So this value is 1.3. So we can write ln c is equals to 1.3. So c will be is equals to e to the power of 1.3. And ln of a is equals to the gradient. We can just simply find the gradient by doing y2 minus y1 upon x2 minus x1. So let's say 1.9 minus 1.6, that is 0.3. and then divided by 1.7 minus 0.9, that is 1.7 minus that is equals to 0.8. So the gradient is 3 over 8. We can write ln of a is equals to 3 over 8, and a will be is equals to e to the power of 3 over 8. Now substituting these values in the calculator, e to the power 3.8, we'll get a is equals to 1.5, and e to the power 1.3, the value of c will be is equals to 3.7. In question 3, the equation x cube equals to 3x plus 7 has one real root denoted by alpha. Show by calculation that alpha lies between 2 and 3. So the method to do this is we'll first write this equation x cube minus 3x minus 7 equals to 0. Now, if the root lies between 2 and 3, then that will mean there should be a change of sign between 2 and 3. And to demonstrate this, so let's say if we make a graph, this is let's say 2 and this is 3. So a graph could be coming in this direction or this direction. What we know is that between 2 and 3, it will be it will move from positive to negative or from negative to positive. So let's first substitute x equals to 2 over here. When we substitute x equals to 2, we'll get 8 minus 6 minus 7. So that will be equals to 2 minus 7, that's minus 5. And when we substitute x equals to 3, we'll get 3 cube 27 minus 9 minus 7. And this value will be 27 minus 16, which is 11, as it is a positive value. So this change of sign from negative to positive basically shows that alpha lies between 2 and 3. In part 2, it says that there are two iterative formula A and B derived from this equation. Each formula is used with the initial value x1 2.5. We have to show that one of these formulas produces a sequence which fails to converge, and then use the other formula to calculate alpha collect to two decimal place. Give the result of each iteration to four decimal place. To show this, what we'll do is we know that if the first value of x is 2.5, so we will have 3 into 2.5 plus 7 to the power of 1 upon 3. And in the other equation, we'll again substitute 2.5 cube minus 7 divided by 4. Now, when we substitute this in the calculator, 3 into 2.5, so 3 multiplied by 2.5 minus plus 7, so plus 7, and then we'll cube root the answer. So we get 2.438. So the next value is 2.438, 2.4384. And when we substitute this over here, we get so 2.5 cube minus 7, and then divided by 4, we will get 2.1565. Okay, so that is 2.5 cube. So 2.5 whole cube minus 7, and then divide by 4. So we are getting 2.15625. And then substituting this value again in both of these formulas, so we'll get 2.4384 times by 3, then plus 7, and then we'll cube root the answer, and that will be equals to 2.42. Now, what we can see is that the values are basically coming very close together in this sequence. This is 2.480, and when I substitute this 2.15 in the second formula, what we will get is so 2.15625 whole cube minus 7, and then divide by 4. Now, in this case, we are getting 0.756. So we can see that the values are not converging to a single value. So the second formula over here, so this was formula A and this was formula B. We can say that this formula is basically failing to converge. Now we'll use this formula to find the value of x. So we'll substitute 2.4280, so 2.428 times by 3 plus 7, and then when we cube root the answer, we get 2.426, 2.4263, and then we find the next value. And we also have to make sure that we give all of our iterations to 4 decimal place. So the next value will be, we'll again substitute this in place of x multiplied by 3, then plus 7, and cube root of the answer, we get 2.4260. 2.4260. So we can say that the value of x correct to 2 decimal place will be 2.43. So we have to give to 2 decimal place, so the final answer will be 2.43. In question number 4, we have to prove the identity tan 45 plus x plus tan 45 minus x as 2 sec of 2x. So for tan 45 plus x and minus x, we'll simply apply the addition formula for tan of a plus b. So if it is plus over here, that is tan a plus tan b. So that will become tan 45 plus tan of x divided by 1 minus tan 45 tan of x. And if it is tan of 45 minus x, the only difference will be that in the numerator we'll have a negative sign and in the denominator we'll have a positive sign. So this will become tan of 45 minus tan of x divided by 1 plus tan of 45 tan of x. Tan 45 is 1, so this will become 1 plus tan in the numerator divided by 1 minus tan in the denominator, plus this will become 1 minus tan divided by 1 plus tan. So taking 1 minus tan and 1 plus tan as our LCM, we will get 1 minus tan, 1 plus tan. So we can write it as 1 minus tan square when we apply the algebraic identity. So this will become 1 plus tan whole square plus 1 minus tan whole square. Expanding the numerator, we'll get 1 plus 2 tan plus tan square plus this will become 1 minus 2 tan plus tan square, and then the denominator will still have 1 minus tan square. So opening up the bracket, so this will become plus minus minus. So 2 tan and 2 tan will cancel out. 1 plus 1 becomes 2. So we'll get 2 plus and tan square plus tan square becomes 2 tan square divided by 1 minus tan square. We can take, so if we take 2 common, we get 1 plus tan square in the numerator and 1 plus tan square in the denominator. Now we know the identity that sec 1 plus tan square is equals to sec square. So we can write 2 sec square theta divided by 1 minus tan square. Now, as we have to bring our, we have to show the identity 2 sec 2x. So we'll try and substitute something in place of tan square. We can write tan square as sine square upon cos square. Taking the LCM, we will get, so 2 sec square theta is in the numerator, and when we take LCM in the denominator, we'll get cos square minus sine square divided by cos square. Now simplifying this, cos square minus sine square, we can use the identity 2 cos 2 theta. We know that cos of 2 theta is equals to cos square minus sine square. So we can write it as 2 sec square theta divided by, in place of cos square minus sine square, let's write cos 2 theta divided by cos square theta. Now in place of sec square theta, we can write cos square theta, 1 upon cos square theta. Bring the multiplication sign, we get cos square theta over here divided by cos 2 theta. Cos square and cos square will cancel out. So we'll be left with 2 upon cos 2 theta. And we know 1 upon cos 2 theta is the same as sec 2 theta, or sec 2x in this case. So we'll get 2 sec of 2x as the identity that we had to prove. Now in part 2, we have to sketch the graph of y is equals to tan 45 plus x plus tan 45 minus x. We know we can write 2 sec of 2x over here in place of 45 plus x and 45 minus x, as we proved in the last part. Now, to sketch a graph, what we'll do is, let's first make the x and the y axis. And we know that sec of 2x is the same as writing 2 upon cos of 2x. So the easiest way to plot this is, let's take x is equals to 0. So if we take x is equals to 0, so we'll write 2 upon cos of 0.
So y is equals to 2 upon cos of 0. Cos of 0 is 1. So we'll get 2. So when x is 0, the value of y is 2. So let's say this is 1 and this is 2. So we'll get the first point. Now let's take x as 45. Now when x is 45, we'll get 2 upon cos of 2 times 45, we'll get cos of 90. Now cos of 90 is 0 and 2 divided by 0 will be an infinity. So at 45, we will have we'll have to make a dotted line and the graph will be going up towards infinity. And then if we take x as 90, so that will become 2 times 90, which is cos of 180. And that will be is equals to, now if we substitute cos of 180 in the calculator, so cos of 180 is minus 1. 2 divided by minus 1 is minus 2. So at 45, it was uh, infinity. Then we'll have minus 1, let's say over here, minus 2 over here. And let's say this is 90. So it is minus 2 at 90. And let's extend this line. And the graph will be like this, coming from infinity. And at becomes minus 2 at x is equals to 90. So this will be the graph for 2 sec of 2x. In question number 5, the equation of a curve is 2x4 plus xy cube plus xy4 equals to 10. And we have to show that dy is equals to as given over here. Now to find the dy dx, we'll differentiate each term individually. So differentiating 2x to the power 4, we'll get 8x cube. And then integrate differentiating xy cube. So we'll take u is equals to x. So u dash will be 1. Taking v is equals to y cube. So v dash will be 3y squared and y dash. So we'll get vu dash, that will become y cube into 1 plus uv dash, that will become 3xy squared y dash plus differentiating 5 power 4, we'll get 4y power 3 y dash is equals to 0. Now to find dy dx, we'll separate these terms. So we'll get 3xy squared y dash plus 4y cube y dash is equals to, and this will become minus 8x cube minus y cube. Now taking y dash as common, which is basically dy by dx, we'll get 3xy squared plus 4y cube is equals to minus 8x cube minus y cube. So we can now write our final answer as dy by dx is equals to, and we just have a negative sign outside it over here. So we can just write negative over here and 8x cube plus y cube over here. And in the denominator, we'll divide this, which is 3xy squared plus 4y squared. So this is so this would have been 4y cube. Okay, so this is a cube over here and this should be a cube over here as well. Now, in part 2, it says, hence show that there are 2 points on the curve at which the tangent is parallel to the x-axis. Now, parallel to the x-axis means it is a horizontal line, which means that the dy dx will be taken as equals to 0. So we have the term for dy dx, which is minus 8x cube plus y cube. So we'll write minus 8x cube plus y cube divided by 3xy squared plus 4y cube, and we'll put it equals to 0. Now, when we cross multiply, this will become 0. We'll get 8x cube plus y cube is equals to 0, as this negative sign will also cancel out. So writing this as y cube is equals to minus 8x cube, and then taking cube root on both the sides, we'll get y is equals to minus 2x. Now, as we have y is equals to minus 2x over here, we can use our original equation to find the value of x or y. So in the original equation, which is 2x power 4, so this is 2x to the power of 4 plus xy cube. So this is xy cube plus y to the power 4 is equals to positive 10. Now in place of y, we can write 2x. So we'll get 2x to the power 4 plus x into 2x power 3 plus, and this is a minus 2x is equals to 10. So we'll get 2x power 4. This will become minus, and this will become minus 8x cube. So minus 8x to the power of 4, and this will become plus 2 power 4 is 16. So 16x to the power of 4 equals to 10. So this is 2 minus 8 minus 6 plus 10 is 10. X to the power of 4 equals to 10. So x will be is equals to x power 4 is equals to 1. And then we'll find the root of 1. So we'll get x equals to plus minus 1. It is the same as finding the square root. We'll get positive and negative values both. As minus 1 to the power 4 is also 1, and 1 to the power 4 will also be equals to 1. Now, once we have the value of x, we can easily find the values of y. So y is equals to minus 2x. We'll write minus 2 into 1 and minus 2 into minus 1. We'll get a plus 2. So when x is 1, the value of y is minus 2. And when the value of x is minus 1, the value of y is 2. And these will be the coordinates where the gradient is parallel to the x-axis. In question 6, the variables x and y satisfy the differential equation as given. We have to solve the differential equation and find the value of x when y equals to 1 upon 3 pi. Now, in the first step, what we do is we bring the y terms with dy. So we'll write it as dy divided by cos square of y, and we'll write it as 4 tan of x is equals into dx. Now we'll integrate both the sides. Now to integrate 1 upon cos square of y, we can first write it as sec square of y dy is equals to 4 tan of x dx. Now the integral of sec square y will be tan of y because the derivative of tan is sec square. So we'll get tan of y is equals to, so the derivative of the integral of tan x will be, now to find the integral of tan x, we'll first write it as sin x upon cos x. Now the derivative of cos x is minus sin x, and we'll apply this integration where if the derivative of the denominator is present in the numerator, the answer becomes ln of f of x. Now the derivative of cos x is minus sin x, so we will multiply by minus and divide by minus as well. So we'll get tan of y is equals to minus 4, and now we'll write this integral as ln of cos x plus c. Now we'll find the value of c. It's given that when x is 0, y is equals to 1 upon 4 pi. So we'll get tan of 1 upon 4 pi is equals to minus 4 ln of cos of 0 plus c. Now cos of 0 is 1 and ln of 1 is 0. So, and tan of 1 upon 4 pi is 1. So we'll get 1 is equals to c. Our equation will now become tan of y is equals to minus 4 ln of cos x plus 1. Now, once we have this, in the next part, it says solve this differential equation and find the value of x when y is equals to 1 upon 3 pi. So we'll substitute x is equals y equals to 1 upon 3 pi. So tan of this will become 1 upon 3 pi is equals to minus 4 ln of cos of x plus 1. Now tan of 1 upon 3 pi, if we substitute this in the calculator, so we'll have to make sure our calculator is in radian mode, and then tan of pi divided by 3. So this will become pi divided by 3. We'll get 1.73, which is equals to root 3. So this will be equals to root 3 is equals to minus 4 ln of cos of x plus 1. We'll take the negative plus 1 on the left hand side. We'll get root 3 minus 1 is equals to minus 4 ln of cos x. Then we'll divide by 4 on the left hand side. We'll get my root 3 minus 1 divided by 4 is equals to ln of cos of x. Now we know using the basic laws of logarithms that if it is ln of x is equals to y, x is equals to e to the power of y. So first we'll do root 3 minus 1 and then divide by 4. So we'll get 0.1830 is equals to ln of cos of x. And now we can, using this logarithm rule, we can write cos of x is equals to e to the power 0.1830. So e to the power of this answer, that becomes cos of x is equals to 1. to 0, and then x will be cos inverse, but cos inverse of this answer is not possible, so we'll have to look for a mistake over here. Okay, so the mistake, I think, is because we did not use a negative sign over here. So this should have been root 3 minus 1 divided by minus 4. And then we'll do shift. So this will become minus 0.813, and then shift e to the power 0.813, that is 0.832. So we'll get cos x is equals to 0.832, and x will be equals to cos inverse of 0.832. So shift cos inverse of the answer, and that will make it 0.5867. And in three significant figures, our answer will be 0.587. In question 7, the complex number u is given by 8 minus 15 iota. We have to find the two square roots of u, giving the answer in terms of a plus iota b. Now, we know that the square root of a complex number is also a complex number. So we can write this as, we have to give our answer in terms of a plus iota b. So we can write it like this. In the first step, we'll whole square both the sides, and we'll get 8 minus 15 iota is equals to, expanding this, we'll get a square plus 2ab iota plus I square b square. I square is minus 1, so we'll get a squared plus 2ab iota minus b squared is equals to 8 minus 15 iota. Now comparing the left and the right hand side, on the right hand side, 2ab is the imaginary term. So we will write 2ab is equals to minus 15, and a square minus b square is the real term, that will be equals to positive 8. We will get b is equals to minus 15 upon 2a. In place of b, now we'll write a square minus 15 upon 2a whole squared is equals to 8. Expanding this, we'll get a squared minus 225 upon 4a squared equals to 8. Cross multiplying or taking the LCM, we'll get 4a power 4, and this will multiply by 4a square. Minus 225 divided by 4a square is equals to 8. Cross multiplying, we'll get 4a power 4 minus 225 is equals to 32a squared. And now we'll get 4a power 4 minus 32a squared plus 225 minus 225 equals to 0. So this is a squared minus 225 equals to 0. Now solving this quadratic equation, we can solve this by middle term breaking as well. We'll get 4a power 4 minus 50a square plus 18a squared minus 225 equals to 0. Taking 2a common, we'll get 2a, so 2a squared common, we'll get 2a squared minus 25 plus, taking 9 common over here, we'll get 2a squared and plus minus minus 25 equals to 0. So one of the values is 2a squared plus 9, and 2a squared minus 25 equals to 0. So we'll get a squared is equals to minus 9 upon 2, and a squared is equals to 25 upon 2. As the square root of a negative number is not possible, so this will cancel out. So a will be is equals to square root of 25 upon 2, which will become 5 divided by root 2. And this will be plus minus. Now, once we have the value of a as 5 upon root 2, we can find the value of b as well. We know that 2ab is equals to minus 15. So writing 2ab in place of a, I can write 5 upon root 2 into b is equals to minus 15. Simplifying this, we'll get 10 upon root 2 b is equals to minus 15. 5 times 2, 5 times 3. So one of the values of b will be minus 3 root 2 upon 2. And the other value of b will become, so now we'll substitute minus the negative value of a, will get minus 5 upon root 2 into b is equals to minus 15. Minus minus will cancel out, and we'll just get a positive answer that will become positive 3 root 2 upon 2. So the two square roots will become 5 upon root 2 minus 3 root 2 upon 2 iota, and the other square root will be, so this will be minus 5 upon root 2 and plus 3 root 2 upon 2 iota. So these will be the two square roots of the complex number. And just for clarity, in the mark scheme, the answer is given as 5 upon root 2 minus 3 iota upon root 2, and this is basically plus minus. Now, when we take the conjugate of 3 iota upon root 2, so let's say 3 iota upon root 2, we multiply by root 2 and divide by root 2, so we'll still get the same answer, 3 root 2 upon 2. So this is the same as the answer given in the mark scheme. In part B, it says on an Argand diagram, shade the region whose points present complex numbers satisfying both the inequalities. Now, whenever we have to um, draw an Argand diagram, the first step will be that we write it as z minus, this will become 2 plus iota less than equals to 2. And then argument of, we'll write it as z minus 0 plus iota is between 1 upon 4 pi and 0. We'll make the x and the y axis. Now it says the distance of z from the point 2 plus iota. So let's say this is 1 and this is 2. And this is iota over here, which is 1 basically. This is the imaginary value. So the distance is within 2. So we'll make a circle of radius 2. So let's say this is 4. We'll have, this is 1. So this will be 3 over here. And 1 point will be at minus 1. We'll make a rough circle from these points, assuming that this is minus 1, this is 3, and this is 4 over here. And then it says the argument from 0 plus iota. So it means from this point, we'll make an imaginary x-axis, and the argument is between 0 and 1 upon 4 pi. So basically, we have to go at an angle of 45, which means when x is 1, y is 1. So if this is 2, this will have moved by 1 unit. So we'll make a straight line like this. And we have to shade the region which is within the circle and between 0 and 1 upon 4 pi. So we'll shade this region over here in the circle, as this shows the argument between 0 and 1 upon 4 pi, and it is also within the circle as well. In question number 8, it says in the first part, we have to express the function in partial fractions in the form as given over here. So we'll just simply first take the LCM. A will multiply by, so A is multiplying by x plus 2 and 2x minus 1. B will multiply by 2x minus 1 and C will multiply by x plus 2, taking the LCM, and we compare it with 4x squared plus 9x minus 8. Now, to find these values, we can start by assuming, let's say if we take x equals to minus 2, A and C values will cancel out. We'll get 4 into minus 2 square, which is 4, plus 9 times minus 2 minus 8 is equals to, so A and C cancels out, so we'll get B into 2 times minus 2 minus 1. So this is 16 minus 18 minus 8 is equals to minus 4 and minus 5b. So this will minus 2 minus 8 will become minus 10 is equals to minus 5b. So b will be is equals to positive 2. Once we have the value of b as 2, now we can take x equals to 1 upon 2 and we will cancel out the a and b values. So now taking x is equals to positive 1 upon 2, we'll get 4 into 1 upon 2 square is 1 upon 4 plus 9 into 1 upon 2 minus 8 is equals to, so a and b cancel out. So we'll just have c into 1 upon 2 plus 2. So this will cancel out. We'll get 1 plus 9 upon 2 minus 8 is equals to 5 upon 2c. Taking the LCM on the left hand side, we'll get 2 plus 9 minus, this will multiply by 2. So 16 upon 2 is equals to 5 upon 2c. 2 and 2 cancels. 9 plus 2 is 11. 11 minus 16 is minus 5. So c will be is equals to minus 1. Now, once we have the values of a and b, to find the value of a, we can just assume any value of x. And let's say if we take x is equals to 0 into the equation, so we'll get 4 times 0 is 0 plus 0 minus 8 on the left hand side is equals to a into, so that is 0 plus 2, that is 2, into 0 minus 1 is minus 1, plus b is 2, so 2 into 0 minus 1, plus c, which is minus 1, so minus 1 into 0 plus 2. So we'll get minus 8 is equals to minus 2a minus 2 minus 2. This will become minus 8 and plus 4 is equals to minus 2a, minus 4 is equals to minus 2a. So the value of a will be is equals to positive 2. Now, once we have these values, in the next part it says, hence show that the integral with the limits can be written as 6 plus 1 upon 2 ln of 16 upon 7. So we have a, which is 2, plus 2 upon 2 x plus 2, minus the value of c is minus 1 upon 2x minus 1. We have to integrate this with the limits 4 and 1. Now, when we integrate 2, we will get 2x. When we integrate 2 upon x plus 2, we'll get 2 ln of x plus 2, minus when we integrate 1 upon 2x minus 1, we'll get ln of 2x minus 1, and we'll divide this by 2. Now, applying the limits, which is 4 and 1, so the upper limit is 4. We'll get 2 4s are 8 plus 2 ln of 4 plus 2 6 minus ln of 4 times 2 8 minus 1 7 upon 2. And then we'll subtract the lower limit, which is 1. So this will become 2 1s are 2 plus 2 ln of 3 minus ln of 2 times 1 minus 1 is ln of 1 upon 2. Now ln of 1 is 0, so this will cancel out. We will get 8 plus, and we can write this as ln of 6 power 2 minus half ln of 7 minus 2 minus ln of 3 squared, which is 9. Now 8 minus 2, that becomes a 6. So we have the first term, which is 6. So 8 minus 2 is 6. And this will become ln of 36 minus ln of, we can write it as 7 to the power of 1 upon 2, or square root of 7, minus ln of 9. Now applying the basic rules of logarithms, we'll get ln of 36 divided by root 7 into 9 in the denominator, as both are negative. So when the terms are negative, we divide them. And then finally, to write it in the form given over there, we can write it as 6 plus ln of, and we can take power 1 upon 2 out. We can write this as, so 36 is square root of 6, and we need 16 upon 7. So we can write it as 9 1s are 9 4s are 4 upon root 7, and 4 can be written as 16 to the power of half, and this is divided by 7 to the power of half. So we can write it as 6 plus ln of 16 upon 7 to the power of 1 upon 2, and then we bring the 1 upon 2 as coefficient and write it as 6 plus half ln of 16 upon 7. In question 9, the diagram shows a curve y is equals to 1 plus x square e power minus half x. The shaded region R is enclosed by the curve, the x-axis, in the lines x equals to 0 and 2. In part 1, we have to find the exact value of the x coordinates of the stationary point. Now we know that stationary point means that the dy dx will be taken as equals to 0. So we'll write dy by dx first, and as the terms are multiplying, so we'll apply the product rule. Taking u as 1 plus x square, so u dash will become 2x, and taking e power minus half x as v, the derivative of e power minus half x will be, we'll multiply with the derivative of the power, which is minus half, and this will remain as it is. Now we'll write vu dash plus uv dash. So vu dash will become 2x e power minus half x plus 1 plus x square into minus half e power minus half x, and that will be equals to 0. Now solving this equation, we'll write 2x e power minus half x is equals to, this is negative. So this will come on the right hand side and become a positive. So this will become 1 plus x square into 1 upon 2 e power minus half x. E power half x and e power negative half x will cancel out. We'll cross multiply 2, so we'll get 4x is equals to 1 plus x squared, and we'll get our equation x square minus 4x plus 1 equals to 0. Now solving this term quadratically, what we'll get is minus, so x is equals to minus b, so that will become plus 4 plus minus b squared. So b squared will be 4 times 4 square is 16 minus 4 ac. A and c are both 1 divided by 2a, so that will be 2. We will get 4 plus minus square root of 12 divided by 2. And simplifying this, you'll get x is equals to 4 plus minus. Now square root of 12 can be written as square root of 4 into square root of 3. That is equals to 2 root 3 upon 2. So the x coordinates will be equals to 4 divided by 2 is 2, plus minus 2 and 2 will cancel out. So we'll get 2 plus minus root 3. And as we just had to find the exact values of the x coordinates, we will leave our answer as it is, which is x is equals to 2 plus minus root 3. In part 2, it says show that the exact value of the area of R. Now to find the area, we'll be integrating the expression, which is 1 plus x square into e power minus half x with the limits 2 and 0, as it is bounded by the lines x equals to 2 and x equals to 0. Now to integrate this, we'll have to apply integration by parts. So the formula for integration by parts is u dv is equals to vu minus v du. So we'll take, as we have an algebraic and an exponential function, we'll apply this rule where algebraic function will be taken as u, which is 1 plus x square. So du will be is equals to 2x, and dv will be taken as e power minus half x, and v, which is the integral of dv, will become, so e power minus half x will divide by minus half, and we can write 2 in the numerator as minus 2 e power minus half x. Now substituting this in the formula vu, so v is minus 2 e power minus half x, so that will become minus 2 e power minus half x into 1 plus x squared minus v du. So v is minus over here, so we can make it plus over here, 2 e power minus half x into 2x. Now we'll again have to apply integration by parts over here, as again we have two different terms that are multiplying. So we'll write it as minus 2 e power minus half x into 1 plus x square. We can write 2 times 2, which is 4 outside the bracket. And now we have x e power minus half x, which we have to integrate. Now again taking u as x, so we'll get u is equals to x, so du will be 1, and dv will be is equals to e power minus half x, which will make v is equals to, as we did earlier, that will be equals to minus 2 e power minus half x. So simplifying this, we'll get minus 2 e power negative half x into 1 plus x squared plus 4 into vu. So vu will become minus 2x e power minus half x minus v du. So v du will make it plus, we can write 2 outside, e power minus half x dx. Integrating this e power minus half x again, we will get minus 2 e power minus half x as it is. So we can just leave this as it is, and integrating this term, we'll get minus 2 e power minus half x one more time. So now simplifying this, we will get minus 2 e power minus half x into 1 plus x squared, and then 4 times 2 will make it minus 8x e power minus half x, and then this is plus 2 times 2 is 4, and 4 times minus 4 will make it minus 16, so this will become minus 16 e power minus half x. Now simplifying this, we can take e power minus half x as common, and write this as minus 2 into 1 plus x squared minus 8x minus 16. Simplifying this, we get minus e power minus half x. So this will become minus 2. Minus 2 minus 16 will make it a minus 18. Minus 2 times x is minus 2x squared minus 8x. And now once you have done the integration, we simply have to apply the limits, which are 2 and 0. So substituting x is equals to 2 first, we'll get e power minus 1 into minus 18 minus 2 times 2 squared will make it 4. So this will be 2 times 4 minus 8 times 2 is 16. So we have substituted x is equals to 2 initially. So this will be x is equals to 2 over here. And then substituting x equals to 0. So we'll get e to the power 0 into minus 18 minus 0 minus 0. This will become e power minus 1 into, so minus 18 minus 8 is minus 26, minus 26 minus 16 is equals to minus 42 minus, and this will become, so e power 0 is 1 and this will become minus 18, which will be equals to plus 18. So we'll get 18 minus 42 upon e, and what we had to prove was 18 minus 42 upon e. So this is the final answer, 18 minus 42 upon e. In question 10, the equations of two lines are given and we have to show that the lines do not intersect. Now, to show that the lines do not intersect, first let's write down each of these equations in parametric form. So this will be 3 minus 1 minus 2 plus lambda minus 1, 1 and 4. And the second equation will be 4, 4 and minus 3 plus mu times 2, 1 and minus 2. So this equation can be written as 3 minus lambda minus 1 plus lambda minus 2 plus 8 lambda. And this can be written as 4 plus 2 mu, 4 plus mu, and minus 3 minus 2 mu. So in the first step, what we will do is, we know this is x and this is y. We can equate them in the first step to find the values of lambda and mu. So we'll write 3 minus lambda is equals to 4 plus 2 mu. So we can write this as minus lambda minus 2 mu is equals to 1. So that this will become our first equation. And using the second equation, minus 1 plus lambda is equals to 4 plus mu. We can write this as lambda minus mu is equals to 4 plus 1, which is 5. This will become our second equation. So solving these two equations simultaneously, this will be lambda minus mu equals to 5. We'll get minus 3 mu is equals to 6. So mu is equals to minus 2. So if mu is equals to minus 2, we can find the value of lambda as well. So lambda minus mu is 5, mu is minus 2. So lambda minus minus 2 equals to 5. This will be equals to 5 minus 2, which is equals to 3. Now we'll substitute the value of lambda over here. So lambda is 3. So minus 2 plus 8 times 3. And we'll substitute mu over here, which is minus 3 minus 2 times minus 2. So this will be minus 2 plus 24, that is 22. And this will be 3 plus 4, which is minus 3 plus 4, which will be equals to 1. Now, as the z values, the z coordinates are not equal, so we can say that, so for lambda, the z coordinate is coming as 22, and for mu, the z coordinate is coming as 1. So we have just shown that the two lines do not intersect. In part 2, it says calculate the acute angle between the directions of the lines. So the directions of each of the lines are minus 1, 1 and 4, and the other direction is 2, 1 and minus 2. So in an equation of a line, this represents a point on the line and this represents the direction for each line. To find the angle between two lines, we apply the product rule. So the scalar product. So this will become AB cos of theta. So this will be minus 1, 1 and 4 times 2, 1 minus 2 is equals to square root of, so 1 square plus 1 square 2, 2 plus 4 square 16, we'll get root 18 multiplied by, so this will become 2 square 4 plus 4 8 plus 1 9. cos of theta. On the left hand side, we'll have minus 2 plus 1 minus 8 is equals to root of 18 times 9. Minus 2 plus 1 is minus 1 minus 8, which is minus 9, is equals to root of 18 into 9 cos of theta. Substituting this in the calculator, we'll get cos of theta is equals to minus 9 divided by root of 18 into 9. Using our calculator for this, we'll get some root of 18 times 9, then minus 9 divided by answer, and then shift cos inverse of answer, we'll get, so the answer is pi upon 4. And if we are giving it in terms of degrees, that will become 45. So the value of theta will be is equals to 45, or if we are giving it in terms of radians, we can give it as pi upon 4 radians. Part 3 is basically a question about planes, which is not part of the syllabus anymore, so we can just ignore this question.